This is a review of the coordinate system with the x-axis and the y-axis and the graph, the flat plane graph that those two axes make. Okay, so let's get started. My two goals during this video are to review the way that this graph works, as well as how to find the distance between any 2 points on that graph. So to get started, let's just pick a few points. Let's pick this point right here and that point right there. We have a convention, that's an agreement around the world, that when we have a graph like this with the x and the y-axis, what we do is we list a point on that graph, the x number first and then the y number second. So this point right here has an x coordinate of 1, 2, 3, 4 and a y coordinate of 1, 2. So that point is described as 4, 2. Hopefully no biggie there. And this point over here is going to be, let's see, its x coordinate is -1, -2, -3, -4. So it's -4. And then its y coordinate is 1, 2, 3, 4. So -4, 4. Okay? So it looks kind of obvious, but how this works is in the first quarter up here, that's called the first quadrant, x and y are both positive, because with x we go toward the right and with y we go up. And in this quadrant, the second quadrant, x is negative and y is still positive. X is negative because we're going left, and y is still positive because we're going up. And down here in this quadrant, the third quadrant, let's put a point right here. This point would be -1, -2, so its x coordinate is -2, and its y coordinate is -1, -2. So in this quadrant, the third quadrant, both x and y are negative. And then in the last quadrant, if I pick a point, say right here, we're going to have a positive value and a negative value. Since our x is to the right, it's going to be positive. In this case, it's over 1, so it's going to be 1. And then in this quadrant, the fourth quadrant, our y values are negative, so it's -1, -2, -3, -4. Okay, so that's a quick review of the 4 quadrants. So that's that. Now, what about finding the distance between any two of these points? For example, if I wanted to find the distance between this point and this point, so my point in the first quadrant and my point in the second quadrant. Well, one thing I could do is I could rip a little piece of paper with my graph on it, and then I could take that and I could lay it along here and I could kind of estimate. That would give me an answer. You know, it might even be a pretty good answer. But a more precise answer can be gotten by making this into a triangle. Why a triangle? That's because in a triangle that has a right angle in it, we can use something called the Pythagorean theorem. This theorem says that if you've got a right triangle, it's got a short leg and a longer leg and a hypotenuse, we'll call that C. It says that a squared plus b squared equals c squared. Once again, this is probably a review for you, but it's something that can show up on the ACT, so we're going to spend a little time on it. So let's look a little closer at this triangle. A and a squared. Well, this side of the triangle, how many units is that? That's 2 units tall. So for A, I'm going to have 2. And then for B, I'm going to have what? 1, 2, 3, 4, 5, 6, 7, 8. So my B is 8. And then I'm going to solve for my C. So let's do this. 2 squared is 4. 8 squared is 64, and that is going to equal c squared. So 68 equals c squared. My whole goal here was to find the length of side C, this length right here. How far apart were these 2 points? So I don't want c squared, I just want c. So you should know that to get rid of a squared, you take the square root. That cancels out the squared. Square and square root are the opposite of each other. But if you take the square root of one side, you got to take the square root of the other side. So c is going to equal the square root of 68, whatever that is. Well, we can kind of estimate that because we know that 8 squared is 64 and 9 squared is 81, so it's got to be somewhere between 8 and 9. So we'll bring up our calculator here and we'll just go 68 and hit the square root button and we get 8.24. Okay, so c equals 8.24. That's just taking 2 decimal places. So that is how far apart those 2 points are. So as practice, what we are going to do next is we are going to find out the distances of the other points from each other. So in this table here, we won't have anything there because the distance between point 3 and point 3 is 0, so those 4 boxes are colored in. What did we do already? We did our first quadrant and our second quadrant number, and we got 8.24, so we'll put 8.24 there. I guess I could write it again here, but what's the point of doing it twice? So we'll just leave the bottom half down here empty. Then that leaves us with 4 problems left to do. We're going to find the distance from our first quadrant number to our third quadrant number. That's going to go here. Our first to our fourth, that's going to go there. Let's see, what's this? Our second quadrant number to our third quadrant number, that'll go here. And then our second quadrant number to our fourth quadrant number, that's going to be this distance right here. That'll go there. So what we'll do right now is we'll pause the video for a few minutes and you'll figure those 4 numbers out, and then we'll come back and we'll go over them together. Alright, so in order, let's take a look at these. Let's do this one right here first. Between the first quadrant number, our point here, and the third, so these two. So we're going to have a triangle that looks like this. And the 2 short sides of that triangle, this one is going to be 1, 2, 3, 4. So that's 4 squared plus 1, 2, 3, 4, 5, 6 squared equals the hypotenuse, or the long side. We'll call it c squared. So 16 plus 36 is what? 36, 46, 52. So 52 equals c squared. So the square root of 52, let's see here, 52, it is 7.21. I'm just going to call it 7.2. What the heck, I'll call it 7.21. So there's that one. Let me clear this a little bit here. So where were we? We're right there. So 7.21. And then let's do from 1 to 4 next. From 1 to 4, that would be this triangle right here. So these 2 sides, that's terrible drawing, but you'll deal. Let's see, 1, 2, 3 squared plus 1, 2, 3, 4, 5, 6. So 3 squared and 6 squared. So let's see here, 9 plus 36 is what? 45 equals c squared. So c is going to be the square root of 45, and that is 6.71. And then blasting right through these, the distance between our second coordinate number and our third coordinate number, let's see, that is going to be, let me use the highlighter this time, from this one to this one. So it's going to be another tall, skinny triangle. It's going to look like this. It's going to be 1, 2, 3, 4, 5, 6, and 1, 2, just 1, 2? Only 2. Okay, so 6 squared plus 2 squared. So that's going to be 36 plus 4. And so that means c is going to equal the square root of 40, whatever that is. And let's see here, 40 square root, we get 6.32. And then let's see here, between our 2 and our 4, we're going to have a triangle that looks like this. It's going to be a big one right here. Whoa, no, not that far. There and there. So this is 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, 6, 7, 8. So 5 squared is 25, 8 squared is 64. So 64, 74, 84, 89. So it's going to be the square root of 89, so a number a little bit bigger than 9. So let's do this on the calculator. What was that again? I already forgot. Don't get old. Okay, 89 square root 9.43. Okay, so 9.43, and then the last one before my graph gets totally sloppy here, between our third and fourth, also this little triangle right here. So let's see here, we got 1, 2, 3 by 1, 2. Okay, so 2 squared plus 3 squared is c squared. So that's going to be 4 plus 9 equals c squared. So 13 equals c squared. Take the square root of everything. C is the square root of 13, and that is 13 square root. It's 3.61-ish. So 3.61. So there you go. There is a quick lesson on looking at the 4 coordinates, 1, 2, 3, and 4, where numbers are positive and negative, and how to find the distance between any 2 points on this graph using the Pythagorean theorem. Thank you very much.